we never directly jump to solving a coding problem. Before we write a program, it's always better to have a rough logic in our mind, so that while writing program, the flow and the way we write program would be far more smooth. So the first question appears when I want to write this program for this. What would be the first question when you want to write a program? What will be the first question? You need to know what you need to find, what this algorithm gonna solve. That is fine with us. We understand that we have to find shortest path. So given this, the next question is, what will be input to my problem? So here input to my problem is a graph. So a question arises, how do I give this graph as an input to my program? So I'm not expecting a right answer, but can you give me at least a quick opinion or a quick guess on what would be best way to represent this graph to my uh, in my Python program? So there are multiple ways to represent a graph. One is adjacency matrix, another is adjacency list, and we have some sort of hybrid versions of representing that, but primarily talking, any approach is basically based on these two fundamental way of representing, adjacency matrix or adjacency list. And if you recall, during Kruskal's implementation, we have we just took the edges from the user and we constructed list of vertices. So what do you think will be better for us? So here we will not take edges as in Kruskal. Even if you do that, you can do that. But what do you think? Like if I want to decide adjacency matrix based representation or adjacency list based representation, what do you think would be better for us, especially considering the Python and the logic which we have to write for this algorithm? Can you comment? Adjacency matrix, okay. Nikhil is saying that adjacency matrix. Mm, any specific reason like why you're preferring list or matrix? So why matrix or list? So look at this approach, like we have visited nodes, unvisited nodes, and table. And are you done with computer networks, CN? Was it in your curriculum or you have completed that? Okay, I think in CN2 you had this algorithm, right? Somewhere in CN, when you study routing algorithms for network layer of TCP/IP stack, you might have been introduced to this algorithm, Dijkstra's algorithm. Okay, okay. So you have, I think you have already written a code for this. If I'm not wrong, there should have been an assignment on implementing Dijkstra's shortest path algorithm. Was there assignment for that? Or instead of asking, was there an assignment? Have you gone through this? I think this is not first time you're going through this Dijkstra's shortest path algorithm. Was it first time or how? So you have written or not? Have you written the code in Dijkstra's for in computer networks? Okay, so you are not written, but I think you have studied that. You have studied that, but no code was written. Okay. So let us work on that. See, if you look at that, I think Shreyans has said list and he has given some explanation. See, if you look at this implementation and the data structures we need, it would be preferable for me to represent graph in adjacency list, because I'll tell you a reason why. See, every time I select a node, I need to explore its neighbors. So if I select 0, the neighbors are 1 and 7. If I select 8, the neighbors are 7, 6, and 2. So in adjacency list, we represent graphs based on their neighbors, like one vertex followed by its all neighbors, second vertex followed by its all neighbors, third vertex followed by all neighbors. Right. So if I can represent it in adjacency list, traversing the graph and moving across it, and the way I access its neighbors would be slightly easier for me. So if you can implement using adjacency list, you can always convert into matrix. Matrix can be converted to adjacency list. So that's not a big deal. So let us represent this graph in adjacency list format. So if I want to represent this in adjacency list format, can you tell me how would that appear in adjacency list? Uh, for example, let me show you here. So how would you represent? For example, if I represent a 0, what are its neighbors? 1 and 7, right? So when I represent 1 here, my question to you is, would you add, okay, this is fine, you understood, 0 nodes neighbor are 1 and 7, 0's node neighbors are 1 and 7, fine. So when I talk about node 1, who are the neighbors of node 1? 0, 7, and 2. So if I write 2, 7, should I also write 0 again, or should I omit this? Should I write this 0 or should I omit this? When I represent a matrix and adjacency list, is it represented? Or you will say already in 0 we have 1, why to write represent 0 as a neighbor of node 1 when we are representing vertex 0? So here, when you look here, you have to write, you have to represent that 0. You cannot ignore that, because why? What could be the reason to write it here? See, here it is bidirectional, but in some case it could be unidirectional as well. Like you might have edge from 0 to 1, and from 1 to 0 you might not have an edge if it is a directional graph. So irrespective of whether this node was already represented or not, you have to mention that in the when you are mentioning the neighbors of 1. So this is fine for representing this graph. So how do you represent cost in adjacency list? So in case of adjacency matrix, the cell value of matrix was enough to represent the cost of edge. But here, how can you represent the cost of edge? Here you are only referring to the neighbor here. So in C and C++, here it could have been some hybrid structure where you can represent the cost of that node. So what I will do is, whenever I represent a node, I will represent it as a list. So the first item of this will be the node vertex, and second will be the cost associated with that. So the second adjacency list of this would be 0 to 7. The cost will be 8. Likewise, when I represent 1, the first neighbor of that 1 is 2, and the cost associated with that neighbor 2 is 8. Likewise, 7, comma 11, and when it connects to 0, the cost will be from 0 to 1, the cost will be 4. Hope you understood this, how I am representing this. So I need to represent this kind of data structure in my Python. So 0, 1, 2 to 8, and each will have it. Now, can you tell me, this is a list, fine, this is a list. So what will be that data structure to represent this entire highlighted data structure here? What will be the data structure? Yes, dictionary looks a good data structure. So let us represent this as a dictionary. Yeah, dictionary is quite intuitive. I think dictionary would work better here because I want to also refer the nodes as an index. So let us use a dictionary here. So just look at this graph. Someone just take some screenshot of this graph because we're going to switch to PyCharm window, and there we will start writing this. We will represent this graph. Okay. So let me switch back to PyCharm window. So once we represent this graph, then we will just repeat the process. What is the process of repeating that? And I have to create this table. Okay, before we write, we have figured out how to represent this graph, how to represent this table. So to represent this table, what we'll do is we'll take plain simple list. One list to represent this column, one list to represent this distance, and one more list to represent this vertex, previous vertex. And if you look at here, what we will do, we will assume that we will have a graph in which each node is labeled starting from 0 to n, right? Let us stick to that format so that our index of list itself acts as a vertex. So we will not maintain a separate column vertex, but the index of this index will itself act as a vertex for our graph representation. Fine. So we will make these table as a lists and graph as a dictionary. Then we will see how to repeat this algorithm or how to write and all that. So let us move to PyCharm window. Let me share the screen. Mm, okay, let me know. Okay, do you see the window, PyCharm window? So as I said, what we'll be writing? Let us make a dictionary. Graph is equal to dictionary. What will be a key value? Key value will be 0, and what this will be, it will be a list, a big list of lists. For example, what was that 0? From 0, I had 1478. This was one in 0, if I'm not wrong. 14 and 78, this is what we wrote there. Okay, so this is for vertex 0. Likewise, we'll have it for vertex 1, and likewise we'll have it for vertex 2, vertex 3, and so on. Just copy paste this. So we have it for 3, we have it for 4, 5, 6, 7, and 8. We don't need comma for 8. Okay, so I have to just fill so look at the graph 2, 0, 1, 0, 1, 8. Okay. So for 1, this should work for 1. Okay, let me write it here. I think if someone can do and someone can find for the notes, now I'm working for 2. If you can find this for note 5, 6, 7, and 8, that would help me in speeding up this code. For 2, it is 1, 8, 2, 8, 4, 3, 7. 2, 2, 8, 2, 5, 3. Okay. For 3, 3 neighbor are 2, 5, 4. 2, 5, 4. 4 neighbor are fourth neighbor. Fourth neighbor are only 2. Okay. Fifth neighbor. Fives are 6 to 2. Let me see if someone. Mhm. Mhm. Hope this graph is represented fine. Okay. So this is the graph which we have represented. Moment has an answer. Values can't be list. I think I didn't get your question. Values can't be list. I think, but we are not modifying that. It would be just a static review. We won't be modifying anything in this graph. So you can even check if you want to check if it is fine. I'll just print. If it prints, then that's fine. No such fine. Okay, so I'm able to print that. See, as long as you do not modify, that's fine. Okay, so I can print that. There is no error in that. Okay, so we have represented this graph, and we will. Okay, so Nikhil has 5. What is 5? He's saying for 5. I think did I do something wrong for 5? What is 5? 5's neighbor are 4, 3, 2, and 6. 5 has a 4 neighbors. What did I write? 5, 4, 10. 5, 3, 14. 5, 2, 4. And 5, 6. Okay, I think I missed one edge for that. What is that? Let me take whatever you have typed. I think I missed 6 for 5. Okay, so now it should be fine, right? Is it correct? Okay. So we have represented this graph. Now let us go further with the further data structures, what we have done. So if you recall, what we have decided is we will maintain distance and previous columns as a two separate list. And if I'm not wrong, uh, what is the initial value of distance? Let me keep distance as a list. And what is the initial value of distance? If you recall our algorithm working, we initialize it with the infinity at the first. But since it is a Python program, we will not initialize it with infinity. Initializing with infinity might be not a good advice in program, and especially when it comes to Python. Remember, in Python, integer values, they technically speaking, they do not have a limit. So if you decide a large infinity number, then that could end up occupying too much of space. So what we'll do is we will arbitrarily select a large value which is not there in graph. Okay, so which is not possible in graph at all. So what we will do is I will set an arbitrarily large value as say 99,999 instead of infinity. And how long I need to maintain distance vector? What should be the length of distance list? It should be based on the number of vertices. Since I am numbering my vertices from 0 to 8, I need to just maintain this as the size of graph. So let us call it as length of graph. So we are not hard coding anything except the graph representation. And I'm just taking triple 5 times 9 just to make sure arbitrarily large number to be called as infinity. Then once we have a distance, and we'll also have a previous. So initially we will set previous as -1 for every node. We won't be having any node with -1. So we will just set minus as for all the nodes. Okay. So this is distance and previous. Now, recall the algorithm, we have been maintaining two sets, visited and unvisited. So what we will do is I'll maintain one Boolean array such that where I will store if I have visited that node or not, right? I will go for a list, a Boolean list. In that, by default, all nodes will be unvisited. And as and when I am done with, for example, when do you mark a node as a visited? For example, if I want to mark node 2 as a visited, I need to traverse all these neighbors. Once I traverse all the neighbors of this node 2, I will mark 2 as a visited one. So what I'll do is I'll just mark a simple array called as visited. So let me call it as array to call node visited, and let me make it as a list with a default boolean value as false, and the size of that would be length of graph. Okay, initially all are unvisited. So graph representation and my table distance previous and node visited. Now what else we'll do is we will now do something called as unvisited. We'll also maintain some list called as unvisited. And we will just initialize this list with all the vertex which I have. So for that, I'll write a for loop for I in range length of graph unvisited dot. I'll append it, unvisited dot append I. Okay, so now what I'll do is I will start exploring one by one from this unvisited. So I'll take first node of this unvisited. I will go to the graph. I'll explore all its neighbors. I'll move to the second one, and that's how I will start going in this. Right. So before I go to that, let us call it as start node. So we have to select some node, right? Start node, or you can also call it a source node. Let us call it as start node is equal to 0. If I select starting node as 0, what else I can initialize? If start node is 0, what is something I can quickly initialize? So start node's distance will be always 0. So this I can do that. Distance of start node will be 0, because that's what initially we start with. Then after doing that, what you need to do is you need to iterate and you have to repeat. So here is our actual logic goes. So now, uh, what should I do and how should I do? So we have initialized all the graph, we have initialized all the data structures required for it, we have initialized the distance, and now start node is set 0. Once the start node is set 0, what should I do? I should explore the neighbors from start node and just move ahead. And once I start with the start nodes and all this neighbors of that start node, uh, see in the table here, let me come back to the node here. Here in the table, initially what's the state of this table? Initially the state of this table will be all vertices, distance is equal to infinity infinity, and this all will be -1 -1 -1, right? So at a specific stage, assume that at a specific stage, if I want to select next node to explore, so here in unvisited we have all these nodes. So when I want to select the next unvisited node, how do I select the next unvisited node? Do I select it based on the neighbors of this, or do I compare something in this and then I select unvisited node? How do I select next unvisited node? What was our approach in that? Yeah, as Rahul has said, we go by minimum of what? So the see, once I'm explored, if I'm exploring 0, what will be the first table value here? If I explore the table with start node is 0, this distance is equal to 0. When I explore 1, the distance of 1 will be 4 and 7 will be 8. Rest all these will be infinity in infinity. Now, in order to select what will be the next node, this 1, 4 or 7, 8. If you recall, we have been selecting based on the minimum value of a distance. I select a node with the minimum distance and I select that vertex if this is unvisited. If it is unvisited, then I select it. Right, that's how I'm doing that. So I need to write a small code which will give me the next unvisited node which has the least distance in that. So initially when I select start node as 0 and when I initialize this, there should be a small block of code or a logic which every time I call that, it has to give me the next unvisited vertex with the least distance at that point. So how do I do that? I need to get one node here, and once I do that, and once I've explored all the unvisited nodes, I remove that node from the unvisited. So my algorithm will stop when I have explored all unvisited nodes. So I can write as long as, so I can write a condition as long as length of unvisited is not equal to 0, I'll enter into loop. So every time I fetch one node, I'll remove that from the unvisited. So we keep on removing nodes from unvisited one by one. So at the end, the unvisited will be empty, and that would mark as an end of our algorithm. So here I need to find a logic which will give me the next node based on distance. Okay, so what we'll do is we'll define a method get, let us call it as get next node, or let us call it as okay, next unvisited node. Let us name is this way, next unvisited node. To this, what we'll do is to this we'll pass the distance list. So from this distance list, it has to give me the one which is unvisited. So what it will do? Can you tell me? I need to give me a distance which is minimum and which is not visited. Can you think of any logic? Minimum distance and not visited. So see, in this distance, some would be visited and some would not be visited as well. Okay, okay. I think I am still on this. Okay. Mm, okay. So I was just defining a method. So define, see, I think I have continued this. So while we'll repeat till unvisited is empty. So every time I remove one node from unvisited, the size of unvisited keeps on reducing. And end of algorithm would be and length of unvisited will be 0, because you explore one, you remove it, you explore from, you remove it from list. So that's how the while loop iterates. But every time I do that, I need an algorithm or a small logic which will give me the next unvisited vertex with minimum distance. So I'm writing a method for that which will directly return that node. So I am passing a distance array. Now from this distance list, you need to return the index of, see, what is this distance? This is actually a list. So this will just contain, so my distance and everything gets updated in this list. From this list, you need to give me the index of a value which is minimum. So let me show you. If I have a list, and if I have a list, for example, let me say temp is equal to, this is some list 1 4 6 0 2 and 2. Okay, temp is a list. I want to find minimum of this temp. What is minimum value in this list? 0. I want index of 0. I want index of 0. How do you calculate the index of 0? Is there in anything in Python which can give me the index of minimum element in list? Mm, yeah, it is actually, we have something called as index. Index is one property of list. So what we do is temp dot index of, okay, if I say index of 1, what I'm getting? 0. If I say index of 9, what I'm getting? 3. What is 3? 0, 1, 2 and 3, right? Yeah, so if you do temp dot index of min of temp, if I do this, EMP. If I do this, I get 4. So is it at 4? Yes, it is at 4. So this will help me in giving the index of that. I hope you understood this, right? So here in my program, so I need to find, okay, I will be getting the minimum from this distance, right? I can get the minimum. But every time I get a minimum, if this is already explored, let us suppose if this minimum is already explored, how do I find next minimum? So I have figured out that I can get the index of this minimum by calling temp.index. But remember, I am using the same distance. Every time you go for this distance array, if you say min, every time you will get the same value, right? Every time you will get 0, 0, 0, because if I initialize the start distance with 0, the minimum will be always this. So I always keep on getting the index of start node. So how do I go for next minimum? For example, let us suppose if I have come and it has returned me index. So in the node visited, I will check if it is visited true or false. If it is false, that's fine. If you find that index node visited is also true, it means that you have marked that index is already visited. Then what should be the logic to give explore for the next minimum? So do you think that this minimum method can give me the first minimum, second minimum, third minimum? So what operation will give me, or which will let me go for first minimum, second smallest, third smallest, fourth smallest? Obviously, we here it looks like we need a sorting. We have to sort it, and then we have to take a proper index of that. But here in distance, if I sort something, what it will do is it will change the order. So I don't want to change the order. So what I will do is, here we'll do some little very complex I will not complex, but something which is new you might have not yet seen. Okay, so let me look at this one. So you see temp, right? Do you see temp? Okay. Now, have you used have you used uh, yes, have you used enumerate? Okay, but if I'm not wrong, have you used enum in C? Enumerated values was also there in C. In C, you had this concept: structures, unions, and enum. What do you mean by enumerate? Okay, so I'll show you an output. You'll understand it better. So this I will take it in temp2 is equal to enumerate, right? Now, what I'll do is I will print this. If so, I need to traverse it. So for um, for say I in temp2 print I. What I am getting in the output? Can you tell me what the output I am getting here? The operation of enumerate is this. What I am getting here: 146902. What I am getting: 146902. What are these values? The first value of this tuple. The first value of this tuple 0, 1, 2, 3. It's an index. So see, it is enum means enumerating the values of this list. It means that it gives me a tuple wherein the first value of tuple for 1 will be the index at which 1 is occurring. So it is at 0, 1 is occurring, at 1, 4 is occurring, at 2, 6 is occurring, at 3, 9 is occurring. That's how. So we get a list, we get a tuple. This becomes a list of tuples, and each tuple gives you index and the value in that list. Are you getting this? Have you understood this? Do you know now what is the use of enumerate? Let me know yes or no. Okay, so why we need it? So I think the best example is sometimes we want to measure that weekdays, right? We call it as weekdays is equal to, so Monday, Tuesday, Wednesday, and so on. Let's say you do this, right? Now, if you do this temp2 is equal to, or what is the code? Okay, this you can do that for each I in enumerate weekdays. We get this one. Are you saying at 0 index is 1, at 1 index is 2? This is called as enumeration. So you get a list of tuples. Now, what I want to do is, so let me clear and let me uh, reset. I want to reset everything. Okay. Now coming back to my original list. I have 9, I have 7, I have 5, I have 2, 4, and 3. Okay. Now, what I want a list of lists which only contains the tuples from enumerated temp list of only even numbers. How many even numbers I have in this? I think only 2 and 4. So what I want a list output from this temp wherein I need to find out at what index the even numbers are there in this temp. So I want a separate sublist which will contain the index and the value. The value will be even and index will be the index at which the element occurs in temp list. So I want to filter out from this temp. See, this will enumerate, this will give me a tuple of this. From that, I want to filter out only those tuples whose value is even, whose second value occurs in temp as an even. Can you suggest a syntax for that? So even numbers, I want this to be list. I want this to be a list. Can you suggest a syntax? Or do you all understand list comprehension? You know what is list comprehension, right? We have already seen that. So what this will contain is, let me write a list here for you. So that should contain a list. So I'm not seeing your chat window. Okay, so what this will do, it will contain a list. So I and J, and what this I and J will be doing? For I and J in enumerate temp, right? This is what I'm doing that. So when you do this enumerate, and I am not sure if it was taken to taught to you earlier in Python syntax or not. For list comprehension, I can always give a if condition. So if this if condition is true, only then this tuple will be included in this, else it will be ignored. If you can write a condition, what could be that if the j, see, if you do enumerate, the first tuple is always index, second tuple is value. If j mod 2 is equal to 0, and now if you print even nodes, what are you getting here? What are these two? 2 is even, 4 is even, and at what index 2 is there? 0, 1, 2, 3, 4, and 5.
This, let me know if you have understood this. Okay. I think the only new part was this we have taken additional. So what I'm doing, what are the values I'm getting from this? I'm putting it in a list format. I want a pair of I and j from I and j in enumerate temp, and I only want to include that if j mod 2 is 0. An alternate to this will be is to use filter. Okay, an alternate syntax for even numbers would be to use a filter. You can also use that filter, but as per performance criteria, list comprehension is far more optimized and quick to execute than a filter. Because in filter we call function, and calling function puts a little overhead. So this, I say, if you have understood this, I'll just retain that as it is. Okay, so moving ahead, this is what I'm doing. So now what I'll do is here in the distance, from the distance index, I will filter out only those values in the distance whose vertex is unvisited. It means that whose node this is unvisited, and from that I'll sort it. So once you sort, you will get the minimum out of that. That's it. Sort it, you will get a minimum. Okay. So you can further optimize it if you require, but that's the easiest syntax which I find. So what you need to do, first you need to filter out. How do you filter out? So what I need a special thing called as unvisited. I'll call it unvisited distance. Unvisited distances is equal to what will be? It will be list of list, right? What will be the list of list? See here, index itself works as a vertex for me, and the second is the distance, and from where we I'll get these values for vertex comma distance in enumerate. What I need to enumerate? Now I need to enumerate distance area, the larger distance which you have passed, and once you have enumerated the distance, once you enumerated the distance, I need to put a filter. What would be the filter? if 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 this vertex should be unvisited, if not vertex, if not, I think I am maintaining this here, I am maintaining this as a list. So in this it should be false. So false means here it should be true. If not, uh, split it in right. If not, mm, node underscore visited of vertex. Okay. So this will give me only those distances. Vertex means index, the vertex and distance, only one which are unvisited. From this, I need to select the minimum. So if I want to select minimum from this, the best thing is to just sort it. Just sort it, because minimum, if I cannot apply minimum here because it is list of lists. So instead of confusing that, I'll just sort it. And now if I want to sort this, how should I sort this? Should I directly sort it, or do I need any custom sorting? So do I need any custom sorting? Unvisited, I will call unvisited nodes is equal to sorted. What I need to sort? I need to sort this unvisited distances, but I cannot sort it on list default ordering. I need to sort it on one field of that. How I want to sort? I have to sort it on vertex or distance. I need to sort it on distance. If I sort it on the distance, what should be the function? So here I use lambda pass item, and I will return on the second value. I want this to be part. So this becomes one input to this lambda, and you need to return a value based on which this will be sorted. So you want it sorted on vertex or distance? I want it to sort it on distance. So distance is second field, it is 1. So once you get this, what you need to return? Where will be the minimum one if I return that visit? Where will be the minimum value? The first element of unvisited will be always the minimum because I'm sorting it. So 0. In that you have to return the vertex. Each element of unvisited node is this. You have to return the vertex. So it is 0 of 0. This will give me the unvisited next distance value. Okay, understood this method? So this keeps on giving me a list item from this which has a minimum distance from unvisited. So now when I have a logic written, what's the first thing I need to do? I need to define the current node. Current node is equal to, now I can call next unvisited node and provide your distance. This will automatically give me the next. So initially when it is 0 and 0, the first node to start here will be 0. Okay. So once you get a current node, what you need to do once you get a current node? You need to explore all the neighbors of that current node. And when you're exploring the neighbors of current node, what you will check for? What you will check for? Let me share your chat window responses. Okay. Okay, no new response. Okay. So what you need to do? Check the distance, right? So I need a for each neighbor, for each neighbor, uh, before I get this, what we want? Am I getting? I think I'm already getting. So for each neighbor, mm, in graph, in graph associated with this current node. If you see, current node will act as a dictionary value. Whatever the value I'm getting, this will act as a key. So I'm traversing this list. So when I say each neighbor, I'm traversing this values. First list, second sublist, and third sublist. Okay, so for each neighbor in graph of current node, what should I do here? If I need to check, right? Now I'm getting a neighbor. Now I need to check that. So what I need to do, if the current distance associated with current node, if the current distance associated with the current node, if it is, what I do is, what I do is here, I am coming to this neighbor node. Okay, initially I am at 0. What I do is I go to 1 and I check if the distance of 1, distance associated this 1 is infinity or not. If it is greater than that, then I update that. Okay, so if this, I think if the distance of neighbor, I think in here in neighbor is a sublist, right? Sublist of 0 means the vertex. Sublist of 1 means the cost. In this graph, this is cost. See, remember, this all is the cost of that edge. This is vertex. So if distance of neighbor, the distance of this neighbor is greater than distance of current node, whatever the current node which you have, current node plus the distance of edge which I have, plus
I think the plus the edge cost. Edge cost means neighbor of 1. So the current table's node value is greater than the sum of this. So I found a better distance. If this is a case, I can update that. What should I do? I need to update distance of neighbor of, I'll update this is equal to the sum, the new value sum. Then if I update the sum, what I do, I change the previous as well. Previous of neighbor of 0 is equal to the current node, right? Then once I do this, okay, I'll do it for each neighbor. And once I'm done with this for, if I come out of this for, I have explored all the neighbors of this current node. So now I'll set node underscore visited for this current node is equal to true. It means that this node has been visited. No need to go for further. Then once I do that, uh, once I have removed that, what should I do is, if I'm done with exploring that, I'm moving to the next node. And what I will do is, since I've explored all this, I will remove this from unvisited nodes. Unvisited dot remove, I'll remove the current node. Okay, so I have received this current node, and from unvisited I have removed this because I've explored all this. I have marked the current node is true and I have just updated. So in the next iteration it goes to here, it is not empty, it will fetch next unvisited node, and it just explores the neighbor. And when it is exploring the neighbor, it will check if the distance, whatever the logic which you have done. So if the current distance of this neighbor is greater than the distance from this node plus the edge cost of this node, then it updates that. So we are not updating for equal. So I think this should work for neighbor in this graph. Okay, so this is graph, this is there. Okay, so I think once we come out of that, we can easily print the format. So now to print it, let us do one thing. We'll do something called as formatted output. What we will do is we will print node distance and both. Okay, so if I say print, have you ever worked with formatted output in Python? Do you know formatted output? The formatted output is something which I can always use this curly brackets. So what I'll do is, the first thing is I will give some spaces. For example, I'll give here 10 spaces. Here I'll give something called text. So you will get a tabular output if I do this. I think it's actually, it's not formatted print, but it's string formatting. Here I can just give the parameters. The first parameter would be the nodes, and the second parameter would be distance. So you will get a string wherein the first string will occupy 10 spaces, second occupy will third will 10, and the value you give here, this first parameter is printed in this curly brackets within the space width of 10 columns, 10 spaces. Here too the same, this value is printed in the space width of this 10 spaces. It's string formatting in Python. After that, what we give is we give a previous node. Okay, then once I print this, what should I do is I need to just print the distance and table, right? After that, I need to just print distance and table. Now what I'll do is I will enumerate. So for I comma j in
enumerate distance I comma j and enumerate distance. I'll just print this. Let me take, so the first value from enumerate, the first value is node. So this I will be the index of this. So index we are using with that 0 to n as an index. So I'll just type the index as it is, and whatever the distance you will get, that will be second parameter, which is j, and I want the previous one. So I will print the value at previous array. In this previous, from the previous array, whatever I have it at I, the index, that should be printed here. I think this should print the entire table. Okay, so let me execute and see if we get, so we will directly get this tabular values for this. So starting node 0 and this, hope this we get a right output. So let me run this. Okay, this is what I get. Does it match with our distances calculated? So do you see this space separated and all this? This is called as formatting. That's because of I have formatted this in this order. Now tell me, are this right or wrong? Are this right or no? Okay, they are right, right? So what was the path I was tracing in that? I think 0 to, if I say 0 to, I think 0 to 4 we have seen. I think 0 to 4 is 21. Can we trace the path also? I think, are these previous nodes also correct? 0 to 4 means 5, from 5 6, from 6 7, and from 7 0. Okay, 0 1 2 5, 0 1 2 5 6 7 2. Okay, I think we are getting right output. So let us do one thing. Initially I have taken one sample graph. Yes, I think they are matching now. So what I'll do is, I now it depends upon you to get this. Okay, I think we have this values there. We get these values. So what we'll do is we'll try it for another graph. So this is one graph. Can you solve this? I want this graph to be represented in this. So this is another graph, and let me write it here. Let me write this. Let me make a test case for this. Give me a second. See, what I'll do is, I will represent this graph in our data structure format. By the time you just calculate some path, I think this I just took it from net. There was one graph, I just took it from that. We have labeled index from 0 to 8, and just find a cost. For example, in order to verify our output, find some cost, minimum shortest cost. By that time, before you do that, I will type the graph into data structures. Are you getting? So what you will work on? You will work on some shortest paths in between from 0 to 8 or some random values, right? And you will compare that with the output which I'm going to run. By the time you solve that and find the shortest path, I will represent this graph in the data structure format the way we have decided, and then I'll execute. So just take a 1 minute. I will start typing that in my graph dataset format. So you solve that problem. Okay. So what I'll do is I'll try to write that in a graph. I'll take this graph as it is in my PyCharm window. Okay, so starting with 0, I get 0 and 0. Okay, so then T from at node 25171 4141. Okay, node 3 has index from 3 303236 3036. One, 62667. Note 5. Note 2, 1, 2, 3, 4, 5, 0, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 6, 6, 3, 2, 7. Eight, 7, 4, 7, 1. Okay. Okay. So hope you have solved and you have output for some. I have just represented that. Let me go back to PyCharm window. Okay. So this is what I have represented. Can you just quickly confirm if I have correctly represented? This was for earlier graph. This is for other graph. Is it right? The graph representation? Okay, so let me run it. I'll just see it. If I get a wrong output, then we'll debug that. Okay, let me run this directly. Okay, and this is what I get. Compare that. Is it right? Is it right? me get this values. Yeah, I will just copy and paste. Okay. See, I have just copy pasted output from there to here. Is it right for this node? Is it right? What is shortest distance? What is shortest between from 0 to 8? Do you agree? So from 0 to 8, previous node is 7. Yes. For 7, previous node is 2. For 7, previous node is 2. For 2, the previous node is 4. For 4, the previous node is 1. And for 1, the previous node is 0. Is it the minimum one? 2 plus 1, 3, 4, 5, 6. If I consider this root for 8, 5 plus 1, 6, it's greater than. Any other root? 5 plus 1 plus 3, okay. 5, I think this is the minimum root. Okay, so output is correct. The output is correct. So I'm getting a proper output, right? Yeah, okay. So let us do one more experiment. What I said, uh, I will reverse the start node. What I'll do is, I will try to reverse the start node. What if we reverse the start node? What do you think? So what I'll do is, what if I make start node as 8? It should work for our algorithm, right? We all always decide the start node, and like from the start node, the algorithm starts exploring the entire graph. If I have start node as 8, let me see what how our program will behave. Okay, I am getting some values. Let me copy this and paste there. You will understand. Okay. Okay. Now tell me, this is for start node 0. And this will be for start node 8. Anything wrong? Start node 8. Okay. So if I say start node 8, okay, so now you should look at from this order, from 0 to, means you need to look at this, that's how you have to look at. Start node is 8. So here start node is 0. So if I take this from 0 to 8, do you see this previous values working? For 0 to 6, from 0 to 8, it says that previous node has to be 1. Okay. For 1's previous node, what is 1's previous node? 1's previous node is 4. 4's previous node is 2. 2's previous node is 7. 7's previous node is 8. Okay, I'm able to trace the path. Here it would be in reverse order. So, okay, here it is 7, then 2, then 2's 4, then 4's 1, and 1's 0. Okay. I hope you understood this program. Have you understood this? Start node. There's a question from Anushka Fatehpur. Okay, start node 0, distance 6. I'm not getting that. What it is? See here when you say that, I hope you are. I think you are confused between this. It means that here start node is 8, so distance from 8 to 8 will be 0. So it is meaning that from 8 to 0 the distance is 6. It's like this is now new source. From 8 to 0 the distance is 6. So algorithm with start node at 0, algorithm with start node at 8. Distance of 6 should be, oh, what are you doing? I'm not getting that. Distance of 6, I'm not getting. Distance of 6 should be 4. Start node 0. Okay, you are saying you're asking for this case 1, right? Start node 0 and distance of 6. Start node 0, distance of 6. Where do I have 6? We are talking about 0 to 6. From 0 to 6. What I'm getting here? Okay, from 0 to 6, I'm getting it from 3. Previous node 3, and from 3 previous node. I think you have to check this. Path is right. This path is right, but distance I'm getting as 5. Okay. Good observation. Good observation. Here I'm getting distance as what did I calculate here? Okay, 5. This I think I highlight in some color or okay. So I think maybe I think see this could be a result. This could be a result if I misinterpreted some of the edge. So instead of 2 and 3, if I have written wrong, it could be wrong representation as well in the program as well. I need to check this distances, how I represented this. Okay. So what I give is, yes, the distance of 3 should be 2. Okay, input. Yeah, I think if we see, if we do an input mistake, it will definitely go wrong. So what can you ascertain? Is it input mistake? This is graph I have represented that. Just see and verify if it is input mistake or if it is something else. We can discuss that in tomorrow's lecture. If it is, this is the input which I have given. Confirm if it is an input mistake or if it is a program's mistake. See, just make sure if it's not a mistake of program. And I think we have exceeded the lecture time. Okay, it's the input mistake. So is it because I represented input in wrong way? Oh, okay. So the program is fine. The input is that. Let me. Okay, so I will not take much of your time. I think I've already exceeded too much of your time. So I will just stop here. But before I leave, have you understood this? Have you understood the program? Let me know if you have understood that. See, we saw the algorithm and we have written this program. And if you see here, we have used enumerate. So we cannot say at what point what syntactic structure will benefit how. Yeah, so what I have done, I have recorded this session. So preferably I'll share this video on YouTube and you can just go through that, because here we are using enumerate. It might be at some point it might be still confusing, but I go through it, you will understand that. So that's how the algorithms implementation goes. In tomorrow's lecture, we will discuss the complexity of this program, and we'll see if we can optimize it. What could be optimization? What is the complexity of Dijkstra's shortest path algorithm? And what is its application, advantages, disadvantages, and how to solve the further one. But as of now, this is it. So I will share this program on GitHub. Go through that GitHub program. Experiment is Prim's algorithm. As Nikhil is asking for Prim's, I think Prim's I have asked students to solve. So before I share my algorithm, I want some students to share their solution. That solution might not be a correct one, but even if you have tried something, that would be better. Okay. So tomorrow we'll discuss Prims. I will see like who students will present and who will not. Can you give me an update? How many of you implemented Prims or tried? Okay, so I'll not take time here. We will discuss that in Telegram group. Oh, hope you understood this program. I'll share this recording and just go through the recording if you felt this program was a little heavy than other programs. Okay, so I'm done from my side. Let us end this lecture. Fine.